Hi everyone, welcome back. In this video, I will provide you a brief overview of what is self-supervised learning, and I will also explain why it is considered a significant breakthrough. You have heard about supervised and unsupervised learning, right? Then what is self-supervised learning? It sounds like a hidden gem, right? Let me break it down for you. In simple terms, self-supervised learning is like teaching an AI to be its own teacher. It's like a magic, but with few lines of codes. Let's start with the basics. We all know that in traditional supervised learning, machines are trained using label data, where humans label each sample. It's like a spoon feeding information to AI. Supervised learning involves training a neural network using label data. Now just picture this. We have a data set filled with different kind of images of different kind of cats, dogs. Now each image in our data sets comes with a label, a clear identifier that tells us whether it's an image of a cat or a dog. Our goal here is to teach our neural network to identify if an image is a cat or dog when you are providing a new image. In simpler words, the network learns to connect images with their labels. This process is effective when we have lots of label data. But getting that data can be tough, expensive, and sometimes time consuming in the real world. This can slow down the supervised learning. Now think about this situation. The internet is full of untitled information waiting to be discovered. But there is a problem. Supervised learning depends a lot on these levels work. Now without them, it's like having a compass without a north direction. So here is the question. Now we have a lot of unlabeled data and we have less number of labeled data. What should we do? This is where unsupervised learning comes in. Here machines analyze data patterns on their own without human direction. Let's discuss about unsupervised learning. The primary goal of unsupervised learning is to uncover hidden patterns or different kind of insights that may not be apparent to humans. Common techniques in unsupervised learning include clustering, dimensionality reduction, and generative modeling. Unsupervised learning is particularly used when we have a large number of unlabeled data and we want to gain insights, detect different kind of patterns, or organize the data in a meaningful way. It is a contrast to supervised learning where models are trained on the labeled data with known outcomes. Here is an example. Now think about it, you have thousands of unlabeled images of animals. You want to automatically group these images into their clusters based on their visual similarities and without adding any specific labels. So first, we can start applying an unsupervised learning technique like t-SNE, that is T-distributed stochastic neighbor embedding, to reduce the high dimensional image data into a lower dimensional space. And also we are preserving the relationship between images. After this dimensionality reduction, we can again use a clustering algorithm such as k-means or a hierarchical clustering to group similar kind of images together based on their visual features. As a result, we might discover that clusters of images containing animals of different kind of shapes, size, and color, even though we didn't provide any labels. This example provides that our unsupervised learning can automatically find patterns and similarity in an unlabeled image data. Here is the result of our unsupervised learning, where each subplot represents a cluster of similar images. Within each subplot, you can see that up to 5 images from each cluster. This visualization allows us to observe how t-SNE and k-means clustering algorithm has grouped different similar kind of images together based on their visual features. Now we learned about supervised and unsupervised learning examples, right? Now how can we create a bridge between two different kind of learning approach? Here self-supervised learning enters. Now think about it, machines to learn from different kind of vast untaped sea of unlabeled data, much like humans learn from their daily experience. It's mind-blowing, right? Another example of self-supervised learning is that it can learn from unlabeled data, discovers different patterns, and eventually masters their individual task without giving any human supervision. Now, self-supervised learning is turning the AI game upside down, right? Here is the secret. Self-supervised learning algorithms transfer unlabeled data into a labeled data. How? By employing different kind of smart techniques like predictive modeling, pre-text task, or leveraging vast amount of unstructured information. Machines become their own teachers, recognizing patterns and extracting valuable insights all of their own. Second is, in NLP terms, I can explain that AI creates an internal representation known as an embedding. Just like how we have a mental picture of an object or an event, the similar way the AI learns to represent data with these powerful embeddings are like fingerprints, enabling the AI to recognize patterns, categorize objects, and provide context to unseen data. The objective of this project is to demonstrate self-supervised learning using image inpainting on CIFAR 10 data. The goal is to learn to predict the missing parts of an image. Now here what we can do, we can load and pre-process our small subset of the CIFAR 10 dataset because it's a huge dataset, right? So what can we do? We can start by loading our CIFAR 10 dataset. Then we can create a masked version of our images for inpainting. Then we are going to define a neural network for the image inpainting task, training the model, then visualizing samples from the original images and the inpainted versions. Now let me explain about the code. A small subset of the CIFAR dataset is taken here. A mask is defined to remove different parts of the images, like masking the right half. Then an image inpainting model is defined. The model takes both original and masked images as input and learns to generate inpainted images. The model then compiled with a mean squared error and the loss for self-supervised learning. The model is again trained for around 50 epochs for the self-supervised learning image inpainting task. Then inpainted images are generated using our trained model. Lastly, original images and inpainted images are visualized. Let's interpret the result. In this visualization, the left side shows the original images, while the right side shows the inpainted images generated by our model. Now I hope you got an idea about self-supervised learning. Now try different projects and let me know. Thank you.